Hey guys, welcome back. So today we're going to talk about 10.3 data distributions, so before we were talking about different charts and how to look at them, analyze them, and interpret the meaning of the data of the charts based on the data that was given. Now we're going to look at the data and organize it by mean, median, mode, and range, and analyze what that says about the data that's provided. So let's get started. So 10.3 here. So from some vocab to get us started. The mean is the average. Median, it says the middle number. So when you order it from chronological order from least to greatest, the median is the middle number. Mode, you think mode, think most. Means most frequent. And then range is the highest or the greatest number subtracted from the lowest or the least number. So here's what that looks like as an example. So first, we always want to order them. So this is an order from 7, 9, 10, 19, and 25. Remember, in order to find the mean means add up all the numbers and divide by the number of data points there are. So in this case, there are 1, 2, 3, 4, 5 data points. So we're going to add these all up and divide by 5. So I go 7 plus 9 plus 10 plus 19 plus 25 and divide by 5. And when I add those all up, I get 70, and then I got to divide that by 5. You have to do those separately, otherwise your calculator will only divide 25 by 5 instead of dividing everything by 5. So add them all up first, hit enter, and then divide by 5. Or you could put these all in parentheses, whatever makes sense to you. All right, mode, there is none because none of them repeat. Median, well, the middle number is 10 because if I cross off these, 10 is what's in the middle. And then my range, my highest number is 25, my lowest number is 7. So 18 is my range. Now let's do the same thing here. So it's 2, then 2 3s, 1, 2, 3, 4, 5s. There we go. So again, to find my mean, I'm going to go 2 plus 3 plus 3 plus 5 plus 5 plus 5 plus 5. And there's 7 of those. So I divide that all by 7. I get 2 plus 3 plus 3 plus 5 plus 5 plus 5 plus 5. Gets me 28. So add those all up, I get 28. Divide by 7, I get 4. The mode, 5 occurs most often. So 5 is the mode. The median is the middle number. So when I look at this, cross these off, 5 is in the middle. And so that's okay for the mean, for the mode and the median to both be the same. And the range is just 5 minus 2, which is 3 in this case. All right, this one, I arrange it in order first. I go 8, 8, 12, 12, and 7. 12, 17. Okay, so I go 8 plus 8 plus 12 plus 12 plus 17. I add that all up and I get 57. Divide it by 5 and I get, right, plus 12. Oops, yeah, I did something wrong. Add those all up, I get 66 and divide it by 6, that's 11. Mode, in this case, there's 2 of them because 8 and 12 both repeat. And then median is again the middle number. So in that case, I don't have my 9 in here. Yeah, that's what I did wrong earlier. So in this case, my median is split between 9 and 12. So in order to find the median in that case, you take the average. So I go 9 plus 12 which is 21, divided by 2, which is going to be 10.5. So even though 10.5 is not a value in the data set, it's still my median because we got to take the average. And then range is 17 minus 8. So that's 9. All right. So that's mean, median, mode, and range. Now, one thing we need to account for when we're finding mean, especially, is outliers. So an outlier is something that's so different from all the other data points that you have to take it in consideration as, should we really count it towards the mean? Because is it an accurate representation of what the actual average is with that data point included? For example, let's say a basketball player normally averages 25 points, but on one night, the player gets injured in the first quarter and only plays 10 minutes and only scores 4 points. Well, 4 points is a lot different than 25. So if you were to include that in the mean or the average, that would drop the average significantly based on something that was a completely extraneous situation where the player got injured. So do you actually include it? Do you not? There's no actual hard, fast rule to what an outlier is. It's just one of those things when you see it, you know it. It's just different from all the others. So for example, at number 4, look how different 29 is from all the other ones. All the other ones are less than 11, and then 29 is just so much higher. So we're still going to do the same thing. This is going to be with the outlier and without it. So we're going to find the mean, median, mode, and range, and see how it compares. So for mean, again, we need to add up all the numbers. So I take 3 plus, let's put them in order first. So I go 3, 7, 10, 11, 29. So add those all up, 10, 20, 31. So 60, right? Yeah, divided by 5 is going to be 12. So with the outlier, it's 12. Now without it, I go 3 plus 7, 10, plus 10, 20, plus 11 is 31. 31 divided by 4 is 7.75. See how much the outlier is making a difference in the mean. It's bringing the mean way up. Median, same thing. With the outlier, it's 10. Without it, it's split between 7 and 10, so it'd be 8.5. Mode, there is none, so that doesn't change anything. Range is 29 minus 3, so it'd be 26, whereas otherwise it'd be without 29, and there it'd be 11 minus 3, so it'd be 8. All right, so see how when the outlier is higher than the rest of them, 29 is way higher than all of them, it brings the mean up. So here the mean is increased by a bunch, the median is increased, and the range especially is increased when there's an outlier. Whether the outlier is lower or higher, the range is going to increase. All right, now here, instead of finding the mean, median, mode, we're just going to talk about how it's going to affect it. In this case, the outlier is going to be 11. It's way smaller than all the other numbers. So in this case, the mean would actually get dragged down by having the outlier in there. And so would the median. Both would be affected. Whereas the range then would still be great just because of the outlier extending the values so much. All right, so let's put this into a real world situation. Mr. Bernard drove those different miles on his last 5 trips. For each question, choose the mean, median, or mode and give its value. So it says, which value describes Mr. Bernard's average driving distance? So average, that's mean. So I go 4 Let's add it. Let's put them all 4, 46, 50, 56, and 64. And I add all those up. 56 plus 64 is 220. And I divide them by 5 because there's 5 of them. It's going to give me 44. Divided by 5. So mean is 44. Now, and yeah, that's the mean. Let's write that in. It says, which value would Mr. Bernard tell his boss to convince him that he spends too much time on the road? Well, the mean is 44. Let's see what the median is based on this data. Median would be, so I got here, 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 here. Median would be 50. In the mode, there is none, so it doesn't make a difference. And then the range would actually tell the boss, well, sometimes you don't drive that far, like, because there's such a wide difference. So in this case, median is what you would use, which in this case is 50. And the reason why is because it indicates more miles driven than the mean does. All right, let's talk about a box and whisker plot. Here's another way of organizing data. This whisker indicates the lowest value. This whisker, that point, indicates the highest value. And these quartiles, so you start with the median, and then the lower quartile is the median of these values. And this quartile is the median of these values. Not the average, the median, the middle number. So in this case, again, we need to organize it in order from least to greatest, and then we'll find the medians for all these. So let's order it first. It looks like it goes 8, 10, 14, and then 15, 20, 15, 18, 22, 22. 30, 33. All right, so the minimum value is 8. The maximum value is 33. The median, let's find that. So cross these all off, is 18. Now let's find, so between all these values and all these values, what's the median? So in this case, it's between 10 and 14, which would be 12. Here it's between 22 and 30. Average between 22 and 30 would be 26. Because I take 22 plus 30 divided by 2, I get 26. So based on this, my box and whisker plot would look like this. My median was 18, so roughly here. My quartile 1 was at 12, so right here. Quartile 3 is at 26, so here, right above 25. And then my minimum was 8, so right here. And my maximum was at 33, so around here. So connect these. And form my whiskers. And that's my box and whisker plot for that data. All right, let's do one more here. The quiz scores of the two students are shown in the box and whisker plots. Who has the higher median? Remember, that's median, that's median. So in this case, Liam has the higher median. Who has the highest score? Well, highest is here and here. So Vicky has a high score. And then it asks, who has the most consistent scores? So what's it mean to be consistent? Consistent means the same. If something is consistent, it doesn't change very much. So in this case, notice that Liam's scores stay within this range, whereas Vicky's scores are in a wider range. So Liam, we'd say, is more consistent. So Vicky, although she has a higher score, she also has the lowest score between the two. So her range is varied way more. Whereas Liam, all his scores stay within a smaller range. It looks like between 8 and 18 or so. So that's how you utilize Fox and Whisker plots, and hopefully you learned a little bit about mean, median, mode, and range, and what those mean as far as analyzing data. So again, if you have guys any questions, please let me know. Thanks.